Hi, everyone. Welcome and thank you for joining today's webinar, Tips from the Industry Expert, the Importance of Particle Size for Cosmetic Products. My name is Julie Chen Nguyen, and I am your facilitator today. This webinar is going to be short, concise, and sweet. We will have a Q&A session in the end. So today with us is Chris Harrison, the CSO of H Square Industries. He came to us with years of practical experience in cosmetics, CBD, and I know that he has visions to expand H Square Industries, our preferred CBD contract lab, into other arenas as well. So let's move on to his talk. Chris, when you're ready, please go ahead and share your screen.
Okay, good morning, everyone. Am I coming through loud and clear?
Yep, and I see the image. Thank you very much.
Okay, great. Obviously, the name of this webinar is Tips from Industry, the Importance of Particle Size for Cosmetic Products. This could be viewed as more of an introductory foray into particle size. We will not dive too deeply into the technical details. HORIBA has a series of excellent webinars that do so, and we will provide a link to that. So, a little bit about myself. I have about 25 years of experience in biotech, pharma, cosmetic brewing, and hemp the last few years. We're based out of Portland, Oregon. The last 6 years, I've really specialized on nanotechnologies, active ingredient delivery, which could apply to cosmetic formulation, beverage, maximizing availability of other active ingredients, and terpene chemistry and things of that sort. We also operate a contract lab just outside of Hillsboro, Oregon. We are the preferred provider for contract service in the hemp industry for HORIBA. We also perform these services in other nanotechnology related industries, 3D print, nano products that disperse water and the like. Okay. Particle size basics. Again, this is a very general overview, but here we have an infographic over here. Particles do make up 80% to composition of a product. We don't really think about that, but they do. They're there. How are they aligned? What size are they? Those sorts of things are important. They can be thought of as the blueprint of a product, the foundation. They make up the framework of your product. Understanding scale. So we look at the infographic. We have 1 micron here, oil smoke, cat allergens. For those with pets, this is particularly applicable. We go lower into the 100 nanometer range. You start to get close to viruses. And then at the 10 nanometer range, you're looking at viruses and suspended atmospheric dust and smog and those sorts of things. A strand of human DNA is about 2.5 nanometers in diameter. The nanoscopic scale appropriately is from 1 to 100 nanometers. So we cover that breadth here, and we can see down that far. Why the HORIBA LA960 S2? It's flexible. The S2 itself is solvent resistant, so we can use this thing for basically any kind of measurement. We can see from 10 nanometers up to 5 millimeters, a wide breadth. Has wet and dry capabilities, so we can do emulsions, creams, pastes, suspensions, powder. We've done soil, other like flexibility, other like materials. So in other words, it's very flexible. It can easily be modified for additional capabilities, such as imaging. If you want to look at morphology, if you want to add a powder feed onto it, you can do that. The software is easy to use. The training really set us up for success. They were there until we had everything down. We were running samples by the end of the day, and the software really handles the brunt of the work that the machine does. Technical support is unmatched. I've never seen the like. I've been around lab equipment for 25 years, and this is the best customer service I've ever seen. Very collaborative. If you approach HORIBA with something you want to work on, they're more than willing to help with that project. Particle size terminology, again, we're not going to dive super deeply into this, but we have an example. This is actually a real world sample that we called out some of the things that are important in particle size. So here we have the span, which would be identified as the particle size distribution. That one actually looks pretty good. The median size, half the particle sizes are above and below this size. So in this case, 5.45. Mode size is the most common particle size found in the distribution. Span, again, is the width of the particle distribution. This one is really good, again, 1.2. And then we have median, which is otherwise called D50, so 50% or above or below. D10, 10% or below this size. D90, 90% or below this size. So D90 would be over in this area and D10 would be in this area. Again, more detailed information in several past webinars. I've attended all of them. I highly recommend everyone check them out. We provide a link there. It's worth your while. Okay, why is particle size analysis important for cosmetic applications? Well, many cosmetic products, most I dare say, include particulates and emulsions. Facial powders, lipstick, sunscreen, creams, lotions. Particle size affects light reflection and diffusion. So over here we have a real world bronzer sample, and this particular client was hoping to be the median to be below 30 nanometer or 30 microns. And we did in fact note that they were there. They also have a really good distribution. So that shows me that this is a very homogeneous product, and therefore it's probably doing the light reflection and diffusion job that they expect it to do. Color and shading are very important, and particle size plays a very key role in that. As light hits and reflects and scatters, that affects how it looks to other people. Why is it important? Well, emulsion stability is in fact tied to particle size and distribution. Particle size affects bioavailability, so less than 100 nanometers is going to penetrate the epidermis more easily. Therefore, if you're looking to deliver an active ingredient, you're more likely to do so if you're in that size range. And the texture and feel of cosmetics is definitely affected by particle size. In particular, you can tell when you have a high quality cream, for instance, versus one that is not so homogeneously blended or perhaps was not subject to the right blending conditions, too much heat, etc. And in fact, high-end cosmetic companies, many of them has particle size analyzers in-house for formulation traceability. How do you repeat a formula if you don't know what your particle size looks like in the distribution? They also want to know what's going in. What do your raw materials look like? For instance, if you're making a foundation, you probably want to hit a certain particle size target range. And they do QC on their finished goods with the same equipment. I cannot stress strongly enough that this should be viewed as highly confidential data. This is proprietary, this every bit as much as an ingredients list or a formulation to me, and it provides potential intellectual property going forward. Definitely can assist with proof of concept, not only in cosmetics, but if you're, for instance, making a water dispersant that has nano beads in it, you probably want to know what the range of your distribution is and what the particle sizes look like within that range. Now we're going to look at a comparison between two products. All information has been redacted so that we don't besmirch anyone's reputation. So they have the very similar ingredients list. I want to stress that the fill dates on these products were very similar. One is a high dollar product, one is not so much. So the less homogeneous product has a clear peak here, a clear peak here, at a very much higher micron range in the 100 micron range. This product here, which was approximately 4 times much retail, has a very solid span It has a very nice peak. And this was reflected in the fact that the texture was incredibly nice, very smooth, uh, not grainy. Also was much more stable. We did an in-house stability study on these at room temp. The one on the left has started to separate clearly and has a liquid layer on top. One on the right looks like it came off the line yesterday. And as you can see, that would probably be important for your shelf presence to not have such a layer sitting on top. And it's clear that it reflects to the stability of to the distribution and the particle size, more so the distribution, quite frankly. This one looks regular, this one not so much. Emulsions, a deeper dive. What is an emulsion? Well, technically it's a fine dispersion of minute droplets of one liquid in another in which it is not soluble or miscible. That's a fancy way of saying oil and water don't mix. The picture on the right is oil and water. When unstable, they will separate like this and look like this. And particle size, the smaller particle size are definitely more stable when they're tightly grouped. And via the distribution, you can tell, and they look like a product that is homogeneous and will stay stable on the shelf. Emulsifiers are surfactants that are used to stabilize emulsions. We know oil and water don't like to mix. They decrease the surface of tension between the oil and the water. They coat the droplets and the particles within that emulsion. What you don't want is coalescing where they can agglomerate together, and then you get these big beads of oil that then join with other beads of oil and end up floating on top of your water product in a beverage, for instance. Emulsifiers then are used in conjunction with mechanical means. High shear agitation, microfluidics, sonication are all used to form that emulsion. The time and heat and things like that can all affect the stability of that emulsion. This is very common in cosmetics and especially beverages, making an oil water soluble, quote unquote. I say quote unquote because technically you're forcing it to be that way. And they don't necessarily want to be that way unless you do an emulsion properly. Next, we will foray into CBD emulsions. It's kind of a hot button topic right now. Here we have a real world sample of a really good emulsion. This was less than 100 nanometers for the median size, a very tight span, and this product went right into water and stayed stable that way. Cosmetic and beverage applications for CBD are seeing huge growth. I don't see that stopping anytime soon. The thing that should be thought of by these the bulk providers of emulsions and things, is that formulation should differ based on the application, and also, in fact, what kind of packaging they're going into. You should not make a cosmetic formulation and expect that to perform the same for a beverage application. You should take into consideration what the other ingredients are. You should take into consideration what the lining of the packaging that you're putting it into is. There's not a one stop fits all, in my opinion. I think it should all be factored into what the application is, what it's going into, what kind of stability are you anticipating. All of these things are important. The particle size and distribution of the dispersed phase, the oil, which would be the CBD in this case, definitely affects the stability and the bioavailability. I mean, we've pulled product off the shelf that looked like an oil and dressing separated on the top. You don't want your product represented that way. You're more likely to have success if you have a emulsion that looks like this on your particle size data. Also, and very importantly, with regards to CBD, particle size impacts the delivery of the active ingredient. So since we're below 100 nanometers here, we would be very anticipatory that the bioavailability of this product would be very high. Anything below that kind of 100 nanometer range is good. Here we have a data overlay. This client actually, we provided separate, this was a raw CBD emulsion and a finished good emulsion. They wanted to see what they look like separately. This is actually an overlay that we provided to them. This is actually the raw CBD emulsion, and this is the finished good. Why is the particle size smaller on the finished good? Well, it had further processing before filling, more blending. The emulsion quality will differ based on the formulation. The mechanical means, are you sonicating? Are you using high shear agitation? And the feedstock. And not all CBD or plant extract is created equal. The feedstock quality has a very powerful effect on the emulsion. The waxes, for instance, and lipids, if they're present in that extract, are going to interfere with the stability of your emulsion. That should be taken into consideration. You probably want to remove those products before providing that for your emulsion. Our experience is that most emulsions have a much larger particle size and distribution than thought by the client. And I think the reasoning for that is they aren't provided that kind of information when they're either buying an emulsion or doing it in-house. So they think that it might be in the 50 nanometer range, but they're not entirely sure. And our experience is that that's not the case. They're typically a little bit larger, not necessarily a bad thing. I look at distribution, quite honestly, as important as the particle size. If you're not evenly distributed and the particles are clumped together in multiple spots, you're more than likely not going to have a stable product. To go a little bit further into stability studies, what we plan to do is collaborate with EVIO Labs. We're planning emulsion stability studies as they correlate to particle size data. We're going to do that on raw emulsions and on finished goods. We'll offer that to clients as a service, but we also want to do that in-house to see if we can kind of determine what things will look like in the future based on real-world data. We're also working with a cosmetic contract manufacturer on particle size stability for their products. They want to start to tie that into their formulation and see if they can consistently hit certain markers. And no way to know that without having this kind of data. In addition, we're working with a bulk provider who does both powder and wet products, and they are actually acquiring data per batch, which is a good idea, and I think something more people should consider. Every batch is different. If you don't know what you have from one batch to another, then how can you be consistent? Goal one then would be to provide a projection of the product appearance on the shelf over time, kind of in real time. Goal two, add particle size analysis as an additional layer of QC for CBD products. Right now, everybody thinks about potency, pesticides, residual solvents, and the like. But you should definitely be considering this as you put it into your product. Are you consistently getting the same input into your product and therefore the same output? Goal three, utilize particle size analysis in conjunction with formulation to identify those preferred production specifications. Again, this allows you to be consistent over time, and you have the kind of information that not necessarily everybody has, and it might be a little bit of an advantage. The conclusion would be that particle size analysis is in fact an excellent application for a wide variety of cosmetic products. We have analyzed creams, gels, balms, lotions, foundation, sunscreen, lipstick, and more just in the cosmetic world. Therefore, manufacturers can kind of adhere to detailed specifications at all steps of the process. You can never know too much about your product. And in fact, there's no doubt CBD and like molecules are the next big trend. They definitely have a place in this world. And particle size analysis allows you to quickly replicate and have reliable data that is otherwise not available to manufacturers. That wraps up this portion of the webinar. I first became aware of particle size analysis about 6 years ago, and immediately when I saw it in action, the light bulb proverbially went off over my head, because I knew that not only did it have applications to the industry I was in at the time, but so many other industries. It's so flexible, and you can do so much with it, and the data is rock solid and repeatable, and there for you to look at over time. So I would recommend everyone delve a little bit further into this via perhaps other webinars or further questions. Thank you.
Thank you, Chris. So we have a question that came in. Can we go ahead and dive right into it?
Excellent, sure.
Cool. So this person wants to know, how do you decide what the concentration of the particles to use when determining the particle size? And I assume that this is when you are measuring particle size and size distribution using laser diffraction LA960 system.
Yes, I think I understand the question is to be what are we looking at as the concentration? This can kind of depend on the client. In fact, if you're looking at the D50 or the median, that may be the most important number to them. Am I answering that the correct way? Are we looking at what is the most important information out of the data?
Maybe. So if this answer did not answer your question, please go ahead and type it into the chat box. But I'll comment that when it comes to laser diffraction, if you have typically like CBD emulsions or creams or sunscreens that you're looking at, the like a concentration of 5 to 10 or 15% of a range is sufficient enough to look at the particle size and size distribution. So when I say 5 to 10%, 15%, we're looking at the amount of light that's being obscured by the particles in the cell. Now, the second question, I understand this webinar is for cosmetics, but I'm curious, if we have bigger particles, how do we determine what concentration is needed for proper measurement? For example, if the light obscured is fluctuating too much, what does that mean? And then there's part 2 of the question is how to stabilize the obscuration and confirm you're getting the right result.
Okay, let me try to tackle that one the way I think I understand it. Larger particles, I'll approach this threefold. Larger particles, where our maximum capability is 5 millimeters. That's typically not an issue. The light, we're actually looking at the laser, and the transmittance that we want to see is typically in the 90% range. That can vary slightly depending on the product or the sample. Where we want it to be stable, that's actually the most important thing before we capture a reading. And we do 3x3 measurements, and by that I mean we do 3 samples and we run each 3 times, and we look for an acceptable less than 5% difference between those samples. I hope that helped.
I will add on to it. I think that, Chris, you're referring to the ISO 13320 guidance where they said your standard deviation for your D10 and D90 should not exceed 3%, should not exceed 5%, and for your D50 should not exceed 3%. And you can double that CV value if you have particles less than 10 micron. So what we see on your slides is actually really good repeatability. Okay, question. You noted that particle size analysis allows fast, replicable, and reliable data, but how much effort is required to get to that point? This person is finding that there is a lot of optimization required to get to the accurate particle size. So what are your thoughts on how much effort is required to get to that point?
Well, part of that relates back to the training that you get from HORIBA. They came to our lab and spent as much time as was necessary to get us comfortable with um, utilizing the equipment and accessing. By the way, there is the software. I can't talk enough about. I mean, it is kind of ingrained into the system that you're able that the ease of use is very high. I'm certainly not a techno wizard, and within one day, we were able to navigate the entire system. We were running real world samples. We tied back into the formulas that existed in the software, and we're in fact able to create some of our own. All this is a part of the very thorough training that you get. And I would further follow that up with that the response to technical questions has been excellent and very responsive and quick. And there is a little bit of learning what kind of solution to disperse. Not everything disperses into the same solution. There's a little bit of trial and error. Does it go into water? Does it have to be an IPA? These sorts of things are variable, and I can't provide an umbrella answer for that. But I will say that the basics are there for you by the time you have this equipment and the trainers have left. And in fact, you can even call them and share your screen with them and have them walk through specific problems with you.
So typically these optimization at the end of the training can be saved into a method. So it's like your standard operating procedures, if you will. So the next time you measure a similar sample, you can readily just open up that sort of method, and it would be as easy as putting samples into the system and click measure. Um,
Correct.
Coming back to how to stabilize the obscuration and confirm you're getting the right result. Okay, so if you have large aggregates or bigger particles, agglomerates, and it's causing your obscuration to fluctuate too much, it means that the system is seeing only a handful of agglomerates as it circulates through the measurement zone. What you might want to do is one, increase the amount of sample that the system can see. So add more samples in, or you can increase the measurement time. So the typical measurement time is 5 seconds. You can increase that to 10 or 15 as we do for soil and sediments that's got a mixture of mud and rocks. So then you allow the system to look at more particles more times and getting you a more statistically significant amount of sample, which means greater repeatability and stable distribution. Next question. Chris, were those three samples that you measured and shown in the slides in your presentation, were they three samples without rinsing system in between?
Which three samples? Usually you have to, if you're doing something like a cream or a gel, you have to clean the system in between. Yes, between other samples.
But those three overlaps, were they three different samples or were they one sample with three repeats?
Those two different samples with all those all had repeats. They're hard to see because they basically are traced over each other. That they were closely matched. It was two different samples.
Got it. Thank you. Next question. What approach to particle sizing would you recommend for primary particle size in the nano range, say less than 100 nanometer? This person's current interest is around 50 nanometer.
Anything less than 100 nanometers. Again, your limitation is 10 nanometers, right? So we have accurately traced things down to 30 nanometers. We haven't seen anything lower than that.
Okay, so this person added, this is for zinc oxide for sunscreen or
For sunscreen,
titanium
yeah.
dioxide at 50 nanometers.
That's extremely low.
Yeah. I'm thinking as a mother myself, how, we're talking about non-nano, non-nano. This is
That
definitely
is,
nano.
that's extremely low. And in fact, at that level, you're getting a lot of dermal penetration.
Mm. But I'll say that if we're looking at 50 nanometers for primary particle size for uh, products like sunscreen, zinc oxide, or titanium dioxide, I would recommend laser diffraction technique as it covers the widest range for a complex system such as cream and sunscreen. So for the LA960 that Chris showed in his presentation, it covers from a dynamic size range of 10 nanometers all the way up to 5 millimeters. Now, we're not suggesting that you have a sample that goes from 10 nanometers all the way up to 5. We're saying that in a system such as yours and sunscreens, laser diffraction would do the best job giving you the best representation of your particles as well as the droplets in the sunscreen.
I would add too, sorry, Julie, going back to the sample, taking the samples, you have to be very careful to make sure they're homogeneous and well representative of the sample overall. I think that I need to stress that a little bit more. If you don't have a good sample, you're not going to get a good result.
Absolutely. Excellent. But that's finding out you don't have a good sample is also information that's important, I think.
Indeed.
Okay, I think this person wanted to know how large can a particle be before an individual begin to feel it?
Hmm. I mean, it would be difficult for me to give an exact answer to that. Harkening back to that example that I provided of the less homogeneous and the more homogeneous,
Hmm.
I believe the median on the less homogeneous was about 7 microns, and of course it had the second peak there 100, and so it definitely had a grainy texture, probably resulting from the 100 micron portion of the sample. So in between there, I don't have an exact answer for that, but I know it was gritty, grainy feeling, and it was probably as a result of the 100 micron particles.
Thank you. So hopefully that answers your question. If not, please feel free to type into the chat box. Um, so there is another question that's regarding to good repeatability and reproducibility. I want to share that I will reach out to you on privately as I can share more applications, notes, and details to it. But basically, Chris, how do you determine good repeatability?
Well, we take 3 samples. We either vortex or through another means make sure everything is homogeneous. We pull a sample 3 times. We run it 3 times. We look for repeatability amongst that. We also look for a lack of interference in the instrument itself prior to capturing the measurement. And if it's, we kind of use that 3 or 5% rule. If it's not falling within that, then we don't feel that we had a representative sample at some point in the process and we start over.
Thank you. So if you have very good repeatability but poor reproducibility, likely you have a sampling issue. So I want to give a little bit more context. This person is also the person who asked about aggregates. So it may be that when you're sampling sample from beaker to sample cell, you missed out on those large, and therefore your reproducibility is not good compared to repeatability.
Yeah, they may be on the bottom or, something similar to that.
Yep. And certainly we'll reach out to you, or you can reach out to us at labinfo@horiba.com. I think that's it for now. So thank you, Chris, for sharing your expertise and wealth of experience that you have out in the field. Again, please don't hesitate to reach out to us at labinfo@horiba.com. So on behalf of our particle group, thank you so much, Chris, and thank you everyone for attending. We'll see you at our next webinar, and don't miss it. All right.
Thank you. Have a great day, everyone.
Thank you. Bye, everyone.